Hello and what's up, amazing people, students, lovers of chemistry, and all the subscribers here. I'm so excited to be here with you on yet another episode of Question for the Day. And today we're looking at one of Faraday's laws of electrolysis. So let's get into what we have. The question on the screen starts by saying, how long? Now, without being a rocket scientist or a professor of cinematology, we know that how long speaks about time. And the question says, how long must a current of 3.0 amperes be passed through molten aluminum oxide to produce 2.7 grams of aluminum? And they've given us some details that we'll need in solving this question. So let's get into it step by step. So the first thing we need to do is to list out our parameters. We've been given the mass of substance to be 2.7 grams. We've been given the molar mass of aluminium to be 27 grams per mole. We've been given Faraday's constant to be 96,500 coulombs per mole, and the number of moles of electrons, we're given it over here. Number of moles of electrons used was 3 electrons. Time is what they asked us to look for because it is unknown, and then the current passed is 3.0 amperes. So now, the next thing to do is to know which formula to use. And the formula that relates all of these parameters together is Faraday's second law of electrolysis. And that law has a mathematical expression that says that the mass of a substance is equal to the current passed, I, multiplied by the time for which that current was passed, multiplied by the molar mass of that substance, divided by the number of moles of electrons multiplied by Faraday's constant. So let's impute our variables into this formula and get our answer. The mass over here is 2.7. This is equal to the current I is 3.0 times T, which is time, multiplied by the molar mass. The molar mass of aluminium in this case is 27 grams per mole. You can see it identified over here. Divided by the number of moles of electrons used was 3 multiplied by 96,500, and that is Faraday's constant. So let's do for the numerator first, and then let's get the value of the denominator. When we say 3 multiplied by T multiplied by 27, what we have is 81 T divided by 3 multiplied by 96,500. That gives us 289,500. So what we have at this point now is 2.7 is equal to 81T divided by 289,500. So at this point, we can simply cross multiply. When we do that, what we have now is just permit me to erase a bit. So I have erased. So when we do that, we have 2.7 multiplied by 289,500 is equal to 81T times 1. So when we multiply these two guys together, 289,500 times 2.7, what we have is 781,650. This is equal to 81T because anything multiplied by 1 remains the same thing basically. So to get T, we divide both sides by 81. So this cancels this. What we have now is 781,650 divided by 81. That gives us 9,650 seconds. When we convert this into hours, that will be 2 hours, 40 minutes, and 50 seconds. Pretty long, right? But that's the amount of time it will take to produce 2.7 grams of aluminium while passing a current of 3 amperes through a solution of molten aluminium oxide. I'm sure you enjoyed every bit of this and you saw how the answer was obtained. To see more episodes of Question for the Day like this, subscribe and turn on the notification bell icon, and I'll see you in the next video. Up until then, my name is David, and all I do here is take the mystery out of chemistry so Chemi can make history.